This video will look at the clutch cycling switch. The clutch cycling switch is the main control used with a CCOT system. Now they can be a fixed cutout pressure or they can be variable. Some will have a little set screw, typically found in between the electrical connectors. This switch senses pressure and assumes temperature. Kind of does the same job as the thermostatic switch in a TXV system, just does it in a different way. Its job is to cycle that AC compressor as required based on the pressure/temperature of the refrigerant coming out of the evaporator in order to prevent that evaporator from freezing to a block of ice. Reminder again that there's a relationship between pressure and temperature with R134. We're going to see this chart on every slide and refer to it often. Before we jump into how the clutch cycling switch works, why it's in there, what if it wasn't there, we need to look back again at the change of state and pressures to realize or refresh ourselves of what's actually happening in this air conditioning system. First off, at the inlet of the orifice, we are going to have a liquid refrigerant under relatively high pressure. How high? Normally someplace between 100 and 250, depending on whether everything's working right, and most importantly, depending on how big the heat load is. How hot is it outside? Just after the orifice, we are going to get a pressure drop, and we're going to have a liquid refrigerant under low pressure. That refrigerant will wind its way through the evaporator, absorbing heat as it goes. What we will have is a liquid vapor mix in the evaporator. And as we get to the outlet of the evaporator, if everything is working right, we should have a vapor. Hopefully. There are some variables there like charge level and blower fan speed, evaporator filter, but if all's well, we should have a vapor. If we don't, I'll put a question mark here. If we don't, that's okay, because we've still got this piece called the accumulator, and it's mounted in the engine compartment in a high heat source area. So if there happens to be some liquid coming out, I'll just put a line here, and we'll put liquid underneath with a question mark. Okay. If there happens to be some liquid coming this way and depositing in the accumulator, there's a standpipe in the accumulator that will draw vapor off the top, and that vaporized refrigerant will go to the compressor, and then the cycle completes of vapor coming out of the compressor and liquid coming out of the condenser. We need to add a few extra things now in order to start looking at what's happening with the cycling switch and how it works. First off, we need a pressure gauge on the low side of the system. Whether we put the gauge here, or we put it at the evaporator inlet, or we put it on the accumulator, within a couple of PSI, that all three of those gauge locations are going to read the same. Next thing we need is a clutch cycling switch, and we're going to mount that on the accumulator. Reason being, accumulators come with a switch port with the Schrader valve, and it's just a simple, convenient place to put the switch. We need some very rudimentary wiring to make this work. We have a battery. There's taking amperage, if needed, to the cycling switch. If the cycling switch is happy, it will send that amperage off to the compressor clutch, engage the drive plate, and of course, we need a ground wire. The last tool we're going to need is the pressure temperature chart, and we're going to refer back to this every picture. We're going to look at the clutch cycling switch in some different scenarios now, some varying heat loads on the evaporator. So to start off with, let's talk about an ambient temperature of about 21 Celsius or 70 Fahrenheit and a sunny day. The vehicle has been sitting out in the sun for a couple of hours, not running. The inside of the cab is going to be hotter than outside because of the sun and the heat radiating through the windshield. So we hop in and we turn the system on, and what's happening at that point? Well, we've got an evaporator here that is going to be sitting at about 80 degrees Fahrenheit or 26.7 Celsius. I had to pick a number. It could actually be higher, but this will work. Because the evaporator is sitting at 26.7 C or 80 degrees Fahrenheit, what we need to do is go over to the pressure temperature chart and find 80 degrees Fahrenheit right here and 26.7 Celsius. And that tells us that our refrigerant pressure is going to be somewhere around that 86.9 psi. The gauge reads 86.9 psi. Now the switch at this point is going to be closed. Okay? The whole low side of the system is relatively hot compared to what it should be, and heat and pressure, remember, always work together with R134. So if the temperature of the components is high, that means the pressure of the refrigerant is going to be high. The switch is set to cut out at 28 psi. We currently have the better part of 87 psi in the system. The pressure working on the diaphragm is enough to keep that switch closed. Amperage will flow from the battery through the switch contacts and down to the electromagnetic coil on that compressor clutch. The drive plate will lock to the pulley, and the compressor will start to pump to give us flow of refrigerant and start to give us some cooling. We're going to stay at the same ambient temperature of 21.1 or 70 degrees Fahrenheit and a sunny day. However, now our system has been running for a while. Let's say maybe 10 minutes with the air conditioning running, and I've changed everything on the low side from red down to pink. So we're not scalding hot anymore, and we're not down into the low temperatures that we're going to get to, but we're getting down there now. It's not hot, it's not low temperature, it's just somewhere in between. And I chose now to look at the switch when the evaporator is running at about 4.4 degrees Celsius or 40 degrees Fahrenheit. Again, what we need to do is make our way over to the pressure temperature chart, find 40 degrees Fahrenheit, which corresponds to 4.4 C, and that tells us that based on this evaporator temperature, the refrigerant should be sitting at about 35.3 psi. Now, 35.3 psi is still enough pressure on that diaphragm to keep the spring collapsed and keep those electrical contacts closed and keep the amps flowing to the compressor. If the amps are flowing to the clutch coil, the compressor will continue to give us flow and it will continue to give us cooling. But we're on our way down. Let's look at what happens after that system has been running just a little bit longer. And the evaporator now has cooled down to the point where it's sitting at 0 Celsius or 32 Fahrenheit. This again is our danger zone because at 0 Celsius or 32 Fahrenheit, any of that water vapor that has condensed to liquid on the fins of the evaporator can start to turn into a solid and actually block the airflow through the evaporator. We don't ever want to block airflow through the evaporator because if we do, we can't get air through the evaporator. If we can't get air through the evaporator, we can't get heat into the evaporator. If we cannot get heat into the evaporator, we cannot vaporize the refrigerant. At a point, this accumulator will fill up and overflow the standpipe and actually send liquid refrigerant to the compressor, which is not going to be good for the reed valves. So we go back to our pressure temperature chart and we're looking for 32 Fahrenheit, which is going to put us somewhere right between these two numbers. Now, a lot of the pressure temperature charts are not accurate to 1 degree or 1 psi. You can find them on the internet, which is what I did. And what I found is that at 28 psi corresponds to 0 degrees Celsius or 32 Fahrenheit refrigerant temperature, evaporator temperature. At that point, the cycling switch goes into action and the contacts here go open. Now, there is still a little bit of pressure pushing on the diaphragm, but at this point, the spring is stronger. So the spring takes over, opens up the switch, stops the flow of amperage to the compressor clutch, and therefore stops the flow of refrigerant, which also stops the cooling, thereby preventing that evaporator from turning to a block of ice and slugging the AC compressor with liquid refrigerant. Here's our next scenario. We started out with the compressor running, and then the evaporator cooled down, and then the evaporator got to the point where the compressor actually shut off because the cycling switch told it to. Now we're at the point where, if we look up here, the cycling switch is still open. Okay? However, the pressure here is starting to rise on the diaphragm, and the diaphragm is trying to overcome the spring, but it isn't quite there yet. So the contacts are still open, and we've still got the blower fan running. We're still putting heat into the evaporator, and now we see that the evaporator temperature has gone from 0 Celsius or 32 Fahrenheit up to 4.4 Celsius or 40 Fahrenheit, and the components are back in the pink zone again. That pressure, that temperature corresponds to a pressure of, once again, 35.3 psi. That's what our gauge reads. That's what is inside of our switch. But again, that 35 psi rising is not quite enough yet to collapse the spring to make the contacts close. So the compressor for the moment is going to stay off. Let's look at the last situation now. The blower fan has been running the whole time, pumping heat into the evaporator. The compressor was off, but as heat is absorbed in the evaporator temperature, of course, is going to start to rise. When that evaporator temperature rises, we come down to our chart again, and we're going to be someplace now in between 40 and 50. And again, I just found a more accurate pressure temperature chart on the internet. And 45 Fahrenheit, 7.2 C corresponds to 40 psi refrigerant pressure. At that point, 40 psi is now enough pressure on the diaphragm to cause the diaphragm to push the contact, overcome the spring, and let's get some amperage flowing through the switch again, down to the electromagnetic coil to engage the drive plate to the pulley, and get that compressor starting to pump. Once the compressor starts pumping, we will get refrigerant flow, which means we'll get cooling, and that process is just going to repeat itself all day long, cycling between low evaporator temperature and moderate evaporator temperature, and low and moderate. Last picture, just to reaffirm the cycle. The compressor was running, the evaporator started to cool down again, and once the evaporator hits that 0 C or 32 Fahrenheit, that will correspond to 28 psi refrigerant pressure, which is not enough pressure on the diaphragm, which means the spring takes over and opens up the contact and stops the flow so that we can prevent that evaporator from turning into a block of ice. Questions often come up with students about why is there a range between cut in and cut out? What exactly is happening there? Well, that range is caused by the spring. Now you have to think with a spring doesn't instantly collapse and instantly expand. It's a variable device. So the harder I squeeze the spring, the more it will contract, but it doesn't just do that instantly. First picture we're going to look at, these are the same states as the previous slides with the system, but just the switch. We're going to look at the clutch cycling switch over here, and it is closed at 40 psi, which is its cut-in pressure. Now, cut-in or 40 psi equals relatively high temperature. This picture, I'm just going to go back and number these. This is number 1. Picture 2 is the clutch cycling switch is now completely open because of low temperature. Or, if we want to look at it at pressure, 28 psi. Now we got to realize, going back to picture number 1, at 40 psi, the switch is closed. I have to drop to 28 psi to get the switch to go open. In between, there's about a 12 psi variance. So as the pressure drops, the spring is trying to expand, but again, it can't do that instantly. So as I'm dropping from 40 to 28, the switch will stay closed. Once we hit 28, the diaphragm cannot win the battle anymore. The spring just takes over and the switch opens up. Picture 3. The clutch cycling switch now is trying to close as the pressure rises, so we could say middle temperature. And of course, because temperature corresponds to pressure, we could also say middle pressure. So picture number 3 showing that switch maybe about halfway closed up here. It's half closed-ish. We might be able to say that that pressure was riding someplace around 35 psi. So we've gone from 28 back to 35. The spring is starting to collapse, but again, it's not going to happen instantly. We need a little bit more pressure on that diaphragm to get the spring to collapse. And that pressure / temperature is once we get back to 40 again, which for this switch is a relatively high temp. So that's what the cycling switch does, is just cycles all day long, monitoring the evaporator pressure and temperature and opening and closing as required to allow that compressor to run when needed without freezing the evaporator. One final thing with this clutch cycling switch cut in and cut out pressures, they are absolutely critical. You cannot control the cut out pressure. What you do is control the cut in pressure. And if it's not proper, your cycle times on the compressor are going to be off. You're either going to freeze the evaporator or you're going to be cycling so often that you'll never get proper cooling.